Okay, so I hope y'all are having a good day. Today we're going to go over dot plots. A dot plot is a visual display of data using a number and dots to represent each data point. The data that repeats itself most often is the mode. This is the one that occurs the most. And in the dot plot, the mode is the tallest value. For example, a survey in 6th grade class asked students to record the number of devices that they had in their home. The information is recorded in the table below. So we're going to use the data to make a dot plot, and we're going to answer the questions that follow. Okay, so 0 devices, that's 1 person, all right? 1 devices, that is 2 people, okay, students. So I put 2 dots, so now I can see so far I have accounted for 3 students, 1 plus, and I have 3 side dots. 1 student has 0, and 2 students have 1. So the number of students that have 2 is 4. The number of students that have 3 is 5. The number of students that has 4 is 7. The number of students that has 5 is 5. Okay, so you can see that coming up here, this is increasing. It looks like we've peaked here. Okay, we went from 1, 2, 4, 5 to 7. It looks like we're coming back down. So looking at 6, it's 4 kids that have 6 devices. There's 2 kids that have 7 devices. There are 2 kids that have 8 devices. A kid that has 9. Okay. So it asks you, what do you notice about the shape of the box plot? So we can say that this is evenly balanced, okay, because it comes up and it goes down. So it looks like it's balanced out evenly, you know? So that's one thing that we're going to say, is that this is evenly balanced, okay? I just wanted to show you an example of a bell curve, so you can see that it actually looks like a bell. It's a common type of distribution. And this is another picture of it, so you can see it kind of peaks in the middle. Each side kind of tapers off evenly into nothing, all right? So back to the matter at hand. So, so when because I've mentioned bell curve a couple times in this videos, I just kind of want to, explain why I keep saying that. Anyway, so this kind of looks like a bell curve, even though I can't draw. And where would you say that most of the data lies in the dot plot? So I would say that most of the data is going to lie, right? This is evenly distributed. And the median, there are 7 instances of 4, all right? One more way to tell that the median is going to be 4 is to just count how many dots you have. So when I added these all up, or you can count how many dots you have on here, because the dot represents, a student. So I got 33. So if I get 33 right, if I was to split 33 evenly, the middle number would be the 17th number. Okay. So when I add this, I went from 1 to 3. I went from 1 to 3 to 7 to 12 to 19. So I know that, okay, 16 is 16 is half, right? And then 17 is going to be that median number, which is right here, because this is 19. And then 18 is also going to be here as well, okay? So basically, 13, after the 13th number, they're all 4s, basically, okay? So that's another way that I know that the median is going to be 17, because the median is the middle number is the 17th number, and that is going to occur right here. All right, so the spread is the variability, so how it varies in data points describes how far the data is from one another. This can also be represented by the range, okay? The median and the mean both represent the center of the data. So when data is skewed, then the mean is the best representation of the data. When data is symmetric, the mean, okay? So when data is symmetric like this, right, it's better, you can take the average and get a good number. If it's skewed right or skewed left, then the mean is going to be thrown off, and I'll show you that in a second. I wanted to talk about the range. So the range in devices is going to be having from 0 devices to 9 devices. So you're going to subtract these, so that's going to be 9 minus 0, and that is 9. And then the mode, the number you see most often, is going to be 4 devices, okay? So coming back down here, so you can see the shape. So you have symmetrical, and then you can see here skewed right, okay? So starting from the right, I can see that it's increasing, but these numbers over here are going to skew my mean, okay? And these numbers over here are also, they're going to skew my mean. So that's why the mean isn't a good representation, because it's being pulled in this instance like to the left, and then the other instance to the right, because of these smaller numbers. So that's why just finding a number in the middle is a better measure for these. But if it's symmetrical, then you can just add them all up and divide it, okay? Okay, so the Ecological Society sampled a green iguana population and made note of the length of each iguana sample. Oh, the data is displayed below in a dot plot, okay? So what is the mean? So when we do mean, we're going to add all those numbers up, okay? So I added all of these up. So I knew 12, 13. You can see I have 3 instances of 14 because there's 3 dots, so forth and so on, okay? So when I added all these up, I got 234. And then I divided it by the number of data points that I had, which was 15. So 15 goes into 23 once. 23 minus 15 is 8. I bring that at 4. And so then I have to do 84. How many times is 15 going to 84? Which is 5 times, because 5 times 15 is 75. When I subtract those numbers, I get 9. Then I bring down a 0. This is taking me into the decimals, okay? So you can see I have a decimal here and a decimal here. And then I bring down this 0. So this is 90. 15 times 6 is 90. So that just ends up being 15.6 for my mean. Okay. So my mean is 15.6. My range. So your range, you're going to subtract the smallest number that has data from the biggest number. Okay. So that is going to be 12 and 19. All right. So when I subtract these two, I get 7. I want to note that even though there's an 11 on here, that does not have a dot, and so that does not count for your range, okay? This is my first point of data, 12, and my last point of data I have is 19. So that's how I find that range. The median is the number in the middle, and so I'm just going to use this. So I just, cross this out until I get to the middle. Okay, guys. 7 on both sides. Okay, so the median, the number in the middle is 16. All right, so to find the interquartile range, I have to look at the numbers on the other sides of these. Okay, so looking here, right? So what's the middle number? So I'm going to cross out an equal amount of numbers on both sides. Okay. So for Q1, I get 14. And then for Q3, I get 17. Okay. So I get 17 minus 14. And remember, all I did was I found my median, right? And then I looked to above my median and below my median, and I found the median of that range. Okay. So then I just do to find the interquartile. So I got my 2 quartiles, Q1 and Q3. So I got, and then I have and it says range, so that means subtract. So it's 17 minus 14, and that means that that answer is going to be 3. Last question says, based on the shape of the data, which measure of center is the best representation? Because basically this is symmetrical, okay? It doesn't like peak at like 15 really, but it's still giving like a bell curve situation here. So it's evenly distributed. Most of the data is here in the middle, and then it kind of tapers off. And so you can see the mean is 15.6 and the median is 16. Because those are so close together, they're only 0.4 apart. Either one of them would be a good representation. The mean is the best representation because when you have a symmetrical data set, you want to use your mean. And if it's not symmetrical, if it's skewed left or skewed right, you want to use your median. But they're both very close together. But the answer would be the mean. Okay, so looking at this one, a local neighborhood is seeking to become certified in energy efficiency. The efficiency scores in each home are displayed in the dot plot below, okay? So the first question is what is the peak score, okay? So that's asking me, what is the mode? What number do I see most frequently? Remember, I told you that that is the one that is the tallest because that has the most dots, so that means it occurs the most, okay? And so that is going to be 68. So remember, I'm looking at peak score, right? It didn't ask me how many people had a peak score of 68. Okay, that would be 6. But it's asking me what is the peak efficiency score, all right? The shape of the data distribution is, okay, I know what it's not. It's not, symmetrical, okay? It's not given the bell curve, all right? So we can see that starting from the left, right, that it is increasing to the right, okay? And so we're going to say that this data distribution is skewed left. To find the range, we are going to subtract the largest and smallest. And I just want to point out that that is not 74 minus 58. That is where the dots begin, okay? That's where the data starts. So that's going to be 72 and 60. Notice that there's no data where 74 and 58 are, okay? So we got 72 minus 60. Okay, so that means that the range is 12, all right? Label each of the following statements as true or false, okay? So it says 22 homes were rated. This is false. So when I added these up, I got 22, okay? So it is exactly half of the ratings were greater than 66. Okay, so this is 66, right? So I added them. So this is 6 here. 70 had 5, and then 72 had 1. And so that gives me 12. And this total is 22, right? So half would be 11. And it says exactly half, which would be 11, and it's not 11. It's 12, so this is also false. Lastly, it says the most common home rating was 66. That is not the truth, right? I would say the most common would be 68 because that is the mode. That is the one that you see most frequently. So all of these are false. Okay. And the next one says, Mr. Tips asked his students to sketch a dot plot that was symmetrical and had data that was close together. Which student completed the task correctly? Okay. So this and this. It's kind of like a bell curve inverted, right? Like for our bell curve, we start here, we peak here, right? And then we decrease, but here we decrease here, right? And then we kind of increase out. So I would say that both of these are symmetrical because we can kind of say like these are mirror images of each other, okay? With this being the mirror, if that makes sense. So make a little bit more. So if you look at these lines, right? So like this is the middle, okay? And for something to be symmetrical, it's kind of like a mirror image here. So like I know that line is kind of crooked, but if you look from here to here, and then if you go from here to here, you can see that it's, you know, cut the same. Versus like here, it's like, hey, where is it going to? You know what I mean? So these are kind of like mirror images of each other. And you'll learn later on that these are like kind of reflections. Anyways, so the answer is both Sarah and Javon. Okay, so the answer is going to be C. All right, so this is a worksheet for practice. So when you're working on this, you should pause this, okay? And then when you pause it, like just do the problems and then come back and at the end and see if you got them right. Okay, so for this one, it says, 4 students were given dot plots to create, sketch the dot plots in 1 through 4, then use A to D to figure out whose is who. So the number of minutes a customer waits in line at the grocery store for curbside. So the first thing we want to do is number all of these. Okay, so now I can go through and start making some dots. So I have 6, 9, 12, 7, 6 again, 10, 8, another 8. Okay, like 6, 6, and 6, and then I have a 7. Okay. So I can see that this data, like automatically I'm seeing that this is not symmetrical, that it's skewed right because the lowest point is on the right and then it's increasing. Okay. The number of miles Mrs. Estrada walks in a week. So we got 1, 2, 0, 5. Okay. Yeah, this does not look symmetrical. And I definitely know the median is not 10.5. Okay. So like here, so this says the number of elementary schools in 10 regional cities. Okay. So this is 5. So I'm put this here. This is 8, 10, 2, right, that's 21, 6, another 16, 3, then right before 12, and now 19 right after 18, right, and then okay, and then this last one says the number of minutes spent on homework over a period of time. So we got 65, 80, 90, 65 again, 70, 75, 100, 90, again, 70, 85, 85, and lastly another 90. Okay. All right. So looking at this information, so I think that this is B, like Julius's data, because it's skewed right, starting from the right, and you can see how it kind of increases here. The number of miles Mrs. Estrada walks in a week. Okay. I think, well, the range for this one is going to be 5 minus 0, which is 5. Okay. So this is going to be Sarah's information here. The number of cities. So looking at this one, so the only 2 left is symmetrical and median of 10.5. So this one, number 4, definitely does not have a median of 10.5. Okay. Because look at it. None of the numbers are there. So this is definitely symmetrical, and it's that upside down bell curve. And then this one is C, so that one must have a median of 10.5, which makes sense that like this would kind of be like. And at this last one, the statement that's not represented by the data is C. Okay, so it is like 11 through 19. That's true. 15. So if you counted all the dots here, we got 3, 5, 6, 9, 10 plus 5, so that's 15. And it's not skewed right because it doesn't start from the right and increase. More than half of the bags had less than 16 pieces of candy for sure, right? Because it's 15 total, right? This is 6, and so this is 9. And half would be 7.5. So definitely more than half had less than 16. Okay? So that's that, you guys. So I hope you have an amazing day. Thank you for doing your best, and I'll see you in class.